Okay, so let's have a look at how we could implement the queue. So let's make our queue, and we're going to do none for 6 again, just the same way we did last time. Now you guys want to make sure to write the declaration that goes with that. Okay, so none times 6, and you guys can do the other stuff here about what it is. Okay, and then we said we had the head of the queue, which is going to start at -1. We said we're going to have the tail of the queue, which is going to be 0. Now, we would also, depending if we're using cyclic or not, we could do queue size, and we could do queue full. Okay, so these are if we were doing a cyclic queue, so we could set the queue size to be 0, and we could set the queue full to be 6. Okay, so this is only if we're doing the cyclic one. If we're doing it the standard way, we don't necessarily need those. So then we need to make our functions. As we said, we had def enqueue, and that's going to contain a letter. I'll put pass for now. And we're going to have def dequeue, and that's not going to have anything in it. So put pass for now. And this is going to be our main program. Mian program, or little program. Anyway, sorry. So when we're going to enqueue, what did we say? Well, we said if the, let's check. We said that if the, I've lost my thingy. Okay, so we're going to enqueue. We want to check if the tail is equal to the head, or we could just check the queue size, couldn't we? So we made these. So when we enqueue, we want to say if queue size is less than queue full, then, so we know the queue isn't full, then we're going to set the queue at position, we're going to set the queue at position tail equal to the letter. Now you're going to see that this isn't going to work. Why is it not going to work? That's sad. So if I was to put enqueue A down here, you see we should get an error, I hope. Let's save and run. I didn't get an error. I feel I should have got an error. I should have got an error because I've got a local variable up here. What if I just print the queue? Let's see, print the queue inside of there. Hopefully it's going to give me a, it's not because Python. Okay, but in most languages, you should not be able to use this stuff down here inside of our functions because this is local and other variables. It's happened before that I've got the error. Python is special, but really for safety's sake, what we want to do is we want to declare all of our different things as global. Now, I genuinely have no idea why that didn't work, because it shouldn't have done, because everything inside of here should only exist inside of here. And so it doesn't make sense for it to exist outside of here. But Python is great, but it's also special sometimes. It's almost like it guesses what you're trying to do, which is nice, but not great when you're trying to teach a concept. Anyway, so I'm going to bring in all my queue stuff as global. Again, I don't recommend using globals. Parameters are generally better, but they do it this way in the exam, so we're going to go with that. So if the queue size is less than the queue full, then the queue at the tail is going to equal the letter, and then we have to add 1 to the tail. So tail equals the tail plus 1. But it's not quite going to work, because what we said before with our cyclic queue was if it's greater than 5, then we're going to revert back to 1. Okay, so we've got to say that if the tail is is greater than, so if it's at position 5, and we're going to add 1, so if the tail equals 5, then we're going to say that the tail is going to become equal to 0. Otherwise, we're going to just add 1 to the tail. Okay, so it's a slight difference, but basically, if we were here, we would want to jump back to here and add it, as you've seen in the theory part of the video, I hope. Okay, now we also want to add to the queue size, just to be sure. So queue size equals queue size plus 1. That's going to add 1 to our queue size. Okay, now eventually our queue size is going to equal the queue full, and it's going to not let us add any more items, I hope. Okay, so when we enqueue, I think that's us. Oh, there's one other thing we have to think about, and that is if it's the first item we add to the queue. So if the, here we've also got to say that if the head, oh no, sorry, that should be down here. I want to say if the head is equal to -1, i.e. it's never been used before, then we want to set the head equal to 0, because basically it's going to start at -1, but let's say when it was empty, it's -1, but then the head is going to become equal to the first element on the queue, which is 0. Okay, so if head was -1 and tail was 0 at the start, then head would become 0 and tail would become 1. That's assuming we added in an A or something there. Okay. All right. So, I mean, let's see if that works. Fingers crossed it will. Okay, so we're going to enqueue A, and then let's print the queue, and enqueue B and enqueue C. Okay, so we're going to enqueue 3 items, and hopefully they will all appear on our queue. Oh, whoa. Oops, double equals, bad. There we go. There we go. Okay, so A's been enqueued, B's been enqueued, and C's been enqueued. Now, if we wanted to dequeue, well, what are we going to do? Well, first of all, we need to check and say if the head is equal to -1, i.e. the queue is empty. Print, sorry, queue empty. Now, the other situation where it's going to be empty is when the or queue size is equal to 0. Now again, I need to bring all these in as global, maybe, depending on how weird Python's feeling, but let's bring them in as global, just in case, okay, because that's kind of what they're expecting in the exam, so let's do it that way. So if the head is -1, or the queue size is 0, then, oops, I need to add to the queue size here as well, sorry, I've done that wrong, that should be there. Okay, so we always add to the queue size. So if we move the tail to the 0, we add to the queue size. If we add 1 to the tail, we move to the queue size. Okay, so dequeue. If the head's -1 or 0, then sorry, the queue is empty. Otherwise, how do we remove an item from the queue? Well, we want to print the queue at the head position. Now that's not removing it, it's just printing it. Like so, and I've got a capital Q here for some reason. So that should output the queue head. Now again, I don't really have to. I might want to clear the data in there just for clarity and set it back to be none. Okay, now I want to remove 1 from the queue size. And I now want to add 1 to the head because the head is moving up. However, I also want to factor in, just like I did before, so if the head was pointing to 5, and then we DQ'd something, we'd want it to roll back round to the 0 again. So we'd say if, down here, we would say not just head plus 1, we would say if the head equals 5, then the head is going to become equal to 0. Otherwise, head equals head plus 1. Oops, I just did the wrong thing there, but should be like that. Okay, so let's just check that. So when we DQ, we say, is the queue empty? If the queue is not empty, we print the item at the head, possibly clear it, remove 1 from the queue size, and then if the head is in position 5, we move it around to 0, otherwise we just add 1 to it. Fingers crossed that's going to work. So let's take some DQ options here. Oops. Let's take some DQ options here and DQ them on here. So DQ and then print the Q and so on. Okay, let's do 2 of those. And then let's NQ a D afterwards just to see if it's working. Okay, so hey, okay, that seems reasonable. So we NQA, NQB, NQC. We DQA, which means it's removed from the start. And then we've got BC left. We DQB, and we've got C left. And then we NQD. Now, I want to go back and double check that if I add past a certain point, it's going to circle around. But rarely do I see circular queues as part of it. So maybe we want to delve into circular queues at a later date and more specificity. However, I think you hopefully get the general idea of how these work in the current situation. Alrighty, see you soon.